Let's consider just a simple example of obtaining the response of the system. Response of the system to Dirac function. So Pavel function, and this is the Dirac function. As we know, here if we denote that this is the timeline of Kate sequences, it's applied here. Okay, at 0. So I have 0, 1, 2, 3, and so on. So we know that sequence or the Laplace transform of this Dirac function yields the following in the case of the discrete system: delta k is equal 1, the same like in the Laplace. So this is easily to memorize or easily to relate to. And we consider the following: k plus 1, the following discrete system representation. So here we will have a 2xk, this is the common example, plus 3 UK. Initial condition x 0 equals 0. So if we have that and we obtain to the Z transform input-output representation, we will obtain x of z, it's equal to the 3 z minus 2 u of z. Okay, and since in this case u of z is just 1, this is the Dirac function. We have that x of z, which is going to become the following expression: 3 divided z minus 2. Now, what happens? How do we obtain response, and how do we find the difference equation when we have this expression? We already know previously that whenever we have the structure z minus a, that was ultimately related to geometric sequence a0, a1, and so on. So in this case, we see that we don't have a z here. In other words, we cannot use this immediate relation to relate from the complex domain into the series expression, and therefore we transform this expression as follows. So we factor z out. This is 3 z 1 minus 2 z minus 1, or we finally get 3 z minus 1, 1 minus 2 z minus 1. Okay, so now when we have that expression, we realize that this expression is nothing but 3 multiplied z minus 1, and here we have something as 1 divided by 1 minus 2 z minus 1. But what is this expression? This expression is already known because we recall that 1 by 1 minus x is 1 plus x geometric sequence. Oops, sorry. This is just x. This is not the this is just x, as I said, and then we have x squared, then we have x cubed, and so on. Okay, and if we have that, this expression becomes, or it is, given as 1 plus 2 z minus 1 plus 4 z minus 2 plus 8 z minus 3 plus, and so on. Okay, so we see that suddenly we obtain the following, that 3 z minus 1, when we multiply all of these, will become, I will just leave one place here, it will become z minus 1 plus 2 z minus 2 plus 4 z minus 3 plus, and so on. Okay, and if we look now in this expression is nothing but the sequence if we are looking in the following sequence. Four and again 4 and then again 8 and so on, and this is again something that has been generated by the following. It's 3 multiplied 2 and minus 1. So from this expression 1, 2, 4, we can generate that this is generated by the 2n minus 1 difference expression, and therefore we have, I purposely left this space at 0 because the final expression for the solution is the following. It's 0 for n equals 0. And how do I know that? I'll explain to you. Because x0 is 0. And here we have a 3 which multiplies 2 and minus 1 for n greater than 0. In other words, n greater than 0 or n equal or greater than 1. So this is what we have as a response. Let us check this by direct substitution. Okay? So we have that for n equals 0, x1 is 2x0 plus 3 delta 0, and this is equal to 3. Okay? Because x0, n equals 0 is x0. So that is what is given in the beginning, that x0 initial conditions were 0. So for n equals 0, we have a 0, but we also know that x1 is generated as a delta 0 x0, which is 3. So x1 is equal to 3. So for n equal 1, we have a now, it's x2, it's 2x1 plus 3 multiplies 0, because this Dirac function outside for delta at 1 is 0. So we have a 2 multiply x1, it's 2 multiplies 3. For n equal 2, x3 is equal to x2 plus 3 multiply 0 again is equal to multiply 6. And so, in other words, the solution that we obtain is given as follows. 3 at 0, 1, 2, 4, 8, and so on. Is the same sequence that we obtained above. Those sequences are the same. As you can see, the solution is 3, 0, 1, 2, 4, 3, 0, 1, 2, 4, 8. So we see that this 0 and this 0, this is the essentially x at 0, x at 1, x at 2 sequence, x at 3, and so on. This is exactly how the system generates the discrete response due to the Dirac input function, and we again calculated that by taking this expression here into the form of 1 minus 2z minus 1, and obtaining this expansion here that we have, and recognizing that this expansion generates the following sequence: 1, 2, 4, and so on. Therefore, in both ways we determine the overall response of the system due to the Dirac function.